Okay, so we are now recording. Yes. Any questions? Okay, so the first topic that we're going to be dealing with is standard algebraic equations. This course is intermediate algebra. Intermediate algebra means that you already know some algebra. Either you placed in this course based on your placement test, or you were you took either 09 or 10 or some kind of class ahead of this, or you showed you that you were able to take this course. This course is a credit-bearing course. You get 3 credits for this course. And I know other colleges tend to call this course college algebra, but this is basically what it is. It's like a college algebra course, and it is a requirement for anybody coming into Medgar Evers to take this course. Everybody has to take this Math 136. Again, it's assuming that you have some basic knowledge of algebra. If you feel that what I'm doing is totally above you, that means that you really have to go back and get into remedial, because this is, again, it's a lot of you have done a lot of this work before, but it is not a remedial course. It is a course, a credit-bearing course. So let's see if you could do, I'm going to put 2 problems on the board, and I'm going to give you a few minutes to work on it. And then if you get an answer, you could just post it on the chat. And when we are finished, when most people are finished, then we'll review these 2 questions, and I'll give you some more. Okay, let me just reiterate. We are starting with solving of basic linear equations. But once we know how to do equations, the next thing we're going to do is going to be inequalities. So let's look at something like this. Suppose I gave you this equation to solve. 2x plus 7 equals -2 times x minus 3, close parentheses, plus 1. Okay, so please solve that equation and try and solve this equation as well. Similar, but a little bit more difficult. 3 times 2x minus 1 minus parentheses 4x plus 3
not much special difference here. But detective, you are seriously
5x
win anyway.
minus parentheses 7x plus 1.
I said, whose pocket are you in?
Okay.
Rather having 10 for basic common sense, $1,000. Say another word, and I'll put you in the lockup. I saw the news coverage about the bombing, and it reminded me of a guy Mark knew. Okay.
Okay, see, quite a few people have already finished examples number one. So let's review number one, and I'll give you some more time after I go over question number one to review question number two. It looks like most people are getting number one correct. Let's just review it. Is there anybody who would like to unmute themselves and sort of lead me through the steps? Anybody willing to get on and start talking instead of me? No. Okay. The answer is no. So I guess I'll have to do the work then. Okay. The question says 2x plus 7 equals -2 parentheses x minus 3 plus 5. Now we remember when we're trying to solve an equation, what we want to do is make sure to get all the x's to one side, or all the variables, whatever letter it is, to one side, and all the numbers, the regular numbers, to the other side. And the first step when we're doing something like that is to make sure there are no parentheses. We want to remove the parentheses, and we do that by doing what's called using the distributive property. So the first thing I'm going to be doing is I'm going to leave this 2x plus 7 alone. And I'm going to remove this parentheses by multiplying everything by -2. That's called the distributive property. We're distributing the 2 to each of these terms. So -2 times x will give me -2x. And -2 times -3 will give us +6. Don't forget, a negative times a negative is a positive. And then I'll just do plus 5. So I've removed the parentheses. Now, if you notice on this side, I have only an x and a number. Over here, I have things that I can combine. So my next step after I've removed the parentheses is to combine any like terms that I see. And I see that the 6 and 5 are like terms. So this will give me 2x plus 7. That just remains the same, equals -2x, and I combine the 6 and the 5, that gives me 11. Okay, so that's my first step. Let's get all as simplified as we can by working each side separately, removing the parentheses and combining like terms. Once you've done that, you want to get all the x's to one side, all the numbers to the other side. Now, it's not absolutely necessary, but I find that the best way to do it is always try to get the x's on the left side, the numbers on the right. When you're doing an equation, it doesn't really make a difference. You could have done it the other way. You could have gotten the numbers on the left and the x's on the right. But when it comes to inequalities, it's absolutely imperative that we always have the x's on the left side. So let's be consistent and always do it that way. So I want to get rid of the x that's on the right side. And since this is a negative 2x, I'm going to do the opposite or inverse example. And I'm going to, instead of having negative 2x, I'm going to do plus 2x. So if I'm doing plus 2x on the right side, I better do plus 2x on the left side. And that'll give me 2x plus 2x, which is 4x, plus 7. Now the negative 2x and the 2x cancel out, and I'm left with equaling 11. I then want to get rid of the 7 that's on the left side, so I'm going to minus 7 because it's the opposite sign, which will give me 4x, because this cancels out. 11 minus 7 is 4. And since I have 4x equals 4, my last step is to divide by the coefficient of the x, and the coefficient of the x, the number in front of the x is 4, so I'm going to divide both sides by 4, and I get x equal to 1. And most people, I saw at least, I'd say at least 10 people did write x equal to 1 as their answer. Okay. Okay, I see a lot of people have given me answers to this one as well, but I'll give you a couple of more minutes to do that, to see if some of you who have not gotten that answer, if you can come up with the answer for the second question. Okay, I think we should start working on that second question as well. I'm first going to erase this top question, and I'm going to rewrite this question on the top, because I think we're going to need a little bit more room than we have sitting there. Okay, so I'm rewriting this. Here is question number 2. We have 3 times parentheses 2x minus 1 minus parentheses 4x plus 3 equaling 5x minus 7x plus 1 in parentheses. Okay. That's the question. And we want to solve this equation as well. Now, what's different about here, I know there are a lot more, there's a lot more going on over here because it's just longer. But the very big difference here is the fact that we have 2 times where we have a parentheses without any number in front of that parentheses. And just like if you have an x standing alone and there's no number in front of the x, it means 1x. The same thing is true when you have a parentheses. It's as if there is a 1 in front of that parentheses. So there really is a -1 over here and a -1 over here. We can really look at these. So anytime you have a parentheses and there's no number in front of it, you can assume that the number in front of it is a 1. It's not like a 0. It means there is one of these. So when I want to remove the parentheses, again, the first thing is to remove all those parentheses is to use the distributive property. So I'm going to multiply everything in this parentheses by 3. 3 times 2x will give me 6x, and 3 times -1 will give me -3. The next thing I see is a -1 in front of this parentheses, which means I have to multiply everything in this parentheses by -1. So -1 times 4x is -4x, and -1 times 3 is -3. No more parentheses. On the other side of the equation, we have this 5x, and again, we have this -1 in front of the parentheses 7x plus 1. So we're going to multiply this, everything in this parentheses by -1, and we will get -7x minus 1. Alternatively, you could look at it as whenever you see a minus in front of the parentheses, all it does is change all the signs of everything in the parentheses. Okay, so now we're at the stage where we don't have any parentheses left, but we do want to make sure that we can now combine like terms. So on the left side, we have a 6x and a -4x. 6 minus 4 gives me 2, so this is 2x. And I have a -3 and a -3. Remember, when you're adding two numbers with the same sign, you combine them. That gives you -6. Again, here might be a place, if you make mistakes on these sign numbers, you might want to use your calculator to do the computations because it will give you the right answers. On the second side, on the right side, I have 5x minus 2x, which I combine gives me -2x and -1. So I've simplified matters a lot. Now I want to bring all the x's to the left side, all the numbers to the right side. So the first thing I'm going to do is I want to get rid of this -2x that's on this right side. So I'm going to do plus 2x. So I have to do 2x over here. So 2x plus 2x will give me 4x minus 6 equals, now this cancels, -1. And now I want to get this -6 that's on the left side over to the right side. So I'm going to do +6. And that'll leave me 4x equals, well, -1 + 6 is 5. And my last step is always, when I have only x's on one side and only numbers on the other side, is to divide by the coefficient, the number that's in front of the x. So I'm going to divide everything by 4. And that gives me my answer equals 5/4. And I saw people gave me answers 5/4. And some people actually put it into their calculators and they got 1.25. Which is the decimal equivalent of the fraction 5/4. Both of these are correct answers. Now, let me just mention that on, let's say, a midterm, which is going to be a multiple choice test, they won't give you both answers. They'll give you one of them. And the likelihood is they will give you the fractional answer. A fraction is usually more accurate than a decimal, though in this case, they're both equally correct and equally good answers. But if you left your answer like this is perfect. If you gave your answer this way, unless you were told not to do it as a fraction, as a decimal, that is also perfect. But again, the fractional answer is probably the better answer. Okay, and I see most people did write 1.25. If you wanted to write it as a fraction, you would have had to use the slash. You could have done 5/4, and that would have given you an answer as well. Okay, so this is basically regular, and this is about as hard as they get, as long as there's no fraction in the equation or decimal. Now, I'm not going to do equations with fractions right yet. I'm going to leave that for a little bit. But I do want to go over, let's try something that has a decimal. As I said, I'm going to leave because people have a tendency to find the whole concept of fractions difficult. So instead of sticking it in here, when we get to a section that will include fractions, as we have a whole unit on fractions, then we'll go over and we'll do the equations that have fractions as well. Okay, so I'm going to erase this. And I'm going to go give you another problem to try. By the way, if you want to ask me a question privately, you can always do it as a private chat. So, I mean, I do encourage people to ask questions in class out loud. I think that it improves the course, it improves the class. But if you want to always ask, you can always send me a private chat. Okay, so let's say I gave you something that looks like this. 0.06x minus 0.05 times 9,000 plus x, and that's going to equal 470. Those of you who have calculators, and I don't care if you use a science, your graphing calculator, certainly for classwork, that's fine. I think you're going to see how efficient and helpful it will be to have a calculator when you're doing something where the numbers are a little bit more difficult. Okay, I'm going to give you a couple of minutes to try this one, and then we'll go on.
Excuse me, what's the last number? 470 or 410?
470.
Okay, thank you.
I was lazy to stand up. I guess that's clearer. Let's see if we can get the right answer to this. Okay. I'm going to do it because I don't have my calculator today. I will bring it next time. You will see I love my calculator. I love doing things on the calculator. I think it's so efficient. And I'd like you to feel the same way about your calculator. So try and get one as soon as possible. But we're going to do this exactly the way we did the other one, using all the same concepts. We're first going to remove the parentheses. So this is going to be left with 0.06x. But this, I have to multiply the negative 0.05 by 9,000. If you did that, you got 450. So that's 900 minus 450. And the negative 0.05 times x is, of course, negative 0.05x. And that equals 470. Okay. Now we do exactly what we did before. We look to combine like terms, and the like terms in this case are the 0.06x and the minus negative 0.05x. And when I subtract 0.06 minus 0.05, that gives me 0.01x minus 450 equals 470. And of course, now I want to bring this 450 to the other side. Which gives me 0.01x equals, well, this is 470 plus 450, which is 920. And now, as I did before, I take the number that's in front of the x, the coefficient of the x, and divide by it. So I'm dividing both sides by 0.01. And here's where you really have to be careful. When you divide, if you're not doing this on a calculator, you could do it by moving your decimal points. If you move your decimal point in the denominator 2 spaces, you'd have to move your numerator decimal 2 spaces as well, which gives you 92,000 over 0.01. Pretty much everybody got 92,000. Somebody wrote 9,200. That's a very common mistake, to make a mistake on a decimal. If you did this on a calculator, you would not make that mistake. So this is where using calculators makes it much easier to work with things like this, which have decimals. Okay. Let's now look at the next topic. I think it seems this class is pretty good on equations. Let's talk about the topic of inequalities. What does the solving an equation mean? A solving equation means you have two things that are equal, and you're trying to find the value of x that will make that statement a true statement. In other words, when x is 92,000, if I would put it into the place wherever I have x, I'd get 470 on this side and 470 on that side. The solving of an equation is really answering the question, what value of x should I take in order to make the original statement that I said a true statement? Let's look at what inequalities look like. So there actually are 4 types of inequalities that you can state. I'm going to give you the 4 types. A, you can have a statement like this: X is greater than some number. I'm just going to pick a number. Let's say X is greater than 5. The second type of statement you can have is something like this: X is less than 5, or 7, or whatever number you have. Those are 2 types. The third type is where you have something like this: X is greater than or equal to 5. And the fourth type is X is less than or equal to 5. So if we compare these things, there are 2 examples, a less than and a greater than, that are straight inequalities. And then you have these 2 that have greater than or equal to, less than or equal to. I think it's easiest to illustrate this if we put it on a number line. Let's look what a number line looks like. A number line is just a straight line. It could be horizontal, it could be vertical, but usually when we talk about a number line, we talk about horizontal. We pick some arbitrary point towards the middle and call it the 0 point. As we go to the right, we have positive numbers. As we go to the left, we have the negative numbers. Now, when I make a statement like X equals 5, there's only that one value that X can be. It's the number 5. An inequality has only one answer. But if I make a statement like this: X is greater than 5, and notice the point is always to the smaller number, the opening is always to the larger number. X is greater than 5. On your number line, well, I really have to go a little further over here. 5. Here's 6. To say X is greater than 5 means you're right over here at 5 and you're going to the right. Any number to the right of 5 is greater than 5. Greater always, if you notice, this looks like the arrowhead. That arrowhead is pointing to the right. That means that when you do the number line, you put your dot at 5 and you make your arrow going to the right. And it's an arrow going to the right because it's extending all the way to forever, or what we call infinity. Now, if you notice at the 5, I made an open circle. Why did I do that? Because at 5, when I say X is greater than 5, 5 is not included there. 5.01 is. Anything a drop bigger than 5 is included, but 5 itself is not included. To show that the 5 is not included, we put a open circle there. What about this one? X is less than or equal to 5. Okay, so here's my number line. Here's my 5. Again, I'm going to start at 5, but to say X is less than 5 means everything to the left of 5. The way the number lines work always work that way. The smaller numbers are to the left, the larger numbers are to the right. So this means anything to the left of 5. Notice I make an open circle at 5, and now I make my arrow going to the, can you see the arrows? I don't know if maybe I should make them in black. notice it's anything from the, what we call negative infinity, all the way up to 5, but not including 5. That's why I left this as an open circle, because to say x is less than or equal to 5 means the number has to be less than 5. It could be negative 100, it could be negative 2 billion, it could be 4, it could be 4.2, but it can't be 5 or anything bigger than 5. Any questions on this so far? Okay, so let's look at this one. This was A, this was B. We're now up to C. Okay, so here's
Can you do an example with a negative?
what?
Can you do an example with a negative 5?
I will. Let me just explain these, and then I'm going to do examples with negatives and all sorts of fractions and whatever, okay? Let's just explain the symbolism. To say x is greater than or equal to 5 means it includes 5, because it says equal to 5, and greater means to the right. The difference between x greater than 5 and x greater than or equal to 5 is simply whether you fill in the circle, which means you include the 5, or you leave it empty, which means the 5 is not included. This little extra line over here is telling you not only are we talking about numbers that are bigger than 5, we're talking about numbers 5 or bigger. It includes the 5. We indicate it by doing a filled in circle. The last one, x is less than or equal to 5, looks like this. Again, we're now, x is less than or equal to 5 means it's anything including 5 and anything to the left of it, anything less than 5. Notice how these arrowheads follow the arrow on the number line. When the arrow points to the right, we make the arrow to the right. When the inequality looks like an arrow to the left, we make that arrow to the left. So these are the 4 types of inequalities you could encounter. Okay. Let's say I wanted to good. Thank you, Tiffany. That was good. So let's say I have a question that looks like this. I'm going to erase this, and I'm going to give you a question, and I'm going to show you how we solve this type of question. Suppose I were to give you something like this. (3x minus 9 is less than or equal to 0. Suppose I give you an inequality that has more than just one x greater or one x smaller. How do we go and solve an inequality like this? Well, basically, the rules of solving inequalities are identical to the rules of solving equations. Think about this not as an inequality sign, but as an equal sign. And go and do all the steps you would have done if this would have been an equation. Well, just like on any equation, I want to get the x's on the left side and the numbers on the right side. So the first thing I'm going to do is I want to get rid of this -9, and I'm going to do it by doing the opposite sign. I'm going to do +9 to both sides, just like in a regular equation, which will leave me 3x less than or equal to 9. Notice, whatever sign this is, I just keep bringing it down. There's going to be one exception to that, but let's not worry about the exception right now. The next thing we do is once I have just the x's on the left and the numbers on the right, is divide by the coefficient of the x. What number is in front of the x? There is a 3. So I'm going to divide both sides by 3. And now we can talk about the exception. You leave the sign of the inequality the same. You don't change what we call the sense of the inequality, except if you're dividing or multiplying by a negative number. If the number, if your coefficient you're dividing by is positive, you leave it exactly the way it was. If I have to divide by a negative number, that's when I'm going to switch the sense of inequality. So in this case, we're dividing by a positive number. We're going to get on this side x. This we're going to leave alone because we're dividing by a positive number. So we leave it less than or equal to, and 9 divided by 3 is 3. And this is called solving the inequality. Just like solving an equation meant get the x alone, solving an inequality is the same thing. You want to get the x alone. And you want to get it, but you can't just within an equation. If I told you, oh, the answer is 1, and a lot of people you did that, let's say to the first equation, you said the answer is 1. When it comes to an inequality, you can't just say the answer is 3. You have to, because there are 4 different ways that an inequality could be written. An equation can only be written with an equal sign, so there's no problem here. But an inequality has 4 different options. So not only must you put in the answer, the 3, you have to make it a whole statement, a whole inequality. You have to say x less than or equal to 3. Now, again, this is the solution of the equality, and you could leave it that way, but very often we want to put the answer on a number line. Let's see what this would look like on a number line. So I go, here's my 0, 1, 2, 3. So here's 3. And I look at this. It says less than or equal to. As soon as I see this extra little line, this equal sign, I know at the 3 I have to fill in the circle. And since this looks like an arrow pointing to the left, from this 3, I make an arrow going to the left. So this is the answer as an inequality. This is an answer on the number line. They're actually, okay, let me not get into that. Let me do one more and then I'll talk about another way of getting the answer. Okay, let's do one more example. Now that we have basically the process understood, let's solve this inequality. Clear board again. So let's say I gave you something like this. 4x plus 20 is greater than or equal to 7x plus 5. Okay, this is a little bit more complex. There's more terms. We don't have any parentheses here, but we could have parentheses just like we have in an equation. We could have parentheses here as well. Okay, how are we going to solve this inequality? Again, we're going to look at this as if we're going to pretend this is an equal sign, and we're going to solve this as if it were an equation, which means we're going to get all the x's to the right. Again, I always want to have the x's on. I mean, all the x's to the left. We want all the x's over here, and all the numbers to the right over here. So the first thing I'm going to do is I want to get rid of the 7x that's on the right side. So I'm going to minus 7x from those sides. It's very important when you're dealing with an inequality that you start with that you get your answer giving the x on the left side and the number on the right side. That's the way it reads the clearest. That's the way you're going to understand it best. That's the way you're going to be able to graph it best on the number line. So we have 4x and negative 7x, which gives me negative 3x plus 20 is greater than or equal to, well, this cancels out, 5. So now I want to get this 20 to the right side. So since it's a plus 20, I'm going to do minus 20, which will leave me negative 3x greater than or equal to 5, and negative 20 is negative 15. So now I've accomplished that I've got all the x's on one side, all the numbers on the right side. I'm fine. But now I have to finish this up. And the way I finish it up is by dividing by negative 3. I'm going to have to divide both sides by negative 3. But here's the one exception, the one thing we have to be extremely careful about, and that's the fact that when you're dividing by a negative number, what it does is it switches the direction of the inequality. So your final answer will come out to be, well, the negative 3's cancel out, and I'm left with x. This was a greater than or equal to, so it'll become a less than or equal to. And negative 5 divided by negative 3 is 5. Negative 15 divided by negative 3 is 5. So that my final answer is x is less than or equal to 5. So this is the one thing you have to be extremely careful about. When you divide or multiply both sides of an equation, of an inequality, by a negative number, you change the sense of the inequality. If we want to give our answer in as an inequality, as a number on the number line, we've given the answer as an inequality. How do we give it on the number line? Okay, again, we have to go to number 5, which is right here. Since it says less than or equal to, I know at the 5 I have to fill in the circle, and I have to draw the arrow going to the left. So here's the answer on the number line. Here's the answer of an inequality. Just to finish this up, let's talk about what happens when we have a third way of giving the answer. Here's one way of giving the answer as an inequality. Here's another way, giving it on the number line. But there is another way, which is called interval notation. which is also a way of expressing the answer of an inequality. With an equation, it's easy to give the answer. You could just give the number. But when it comes to an inequality, you have to be very careful either to write it as an inequality or to show it on the number line or to give it in what we call interval notation. So let me indicate how to write interval notation. I'm going to start with this one because it's already on the board. And then I'm going to give you, because this is just one type, this is a less than or equal type. We'll go through the 4 types. Okay. What's wrong with using a number line? It takes a lot of room. You have to put it in space for all these missing numbers that are really doing nothing there. What is important for you to know about this? Well, one of the ways you can look at an interval is a section of the number line. It's one piece of the number line. And what's important for you to know is where does the section start and where does it end? Now, when you're talking about an interval on a number line, you're always going to give as your first number the number on the left, and your second number is going to be the number on the right. Now, in this case, the arrow is indicating that it's going all the way to negative infinity. Remember, the sideways 8 is a negative infinity. So now negative infinity and infinity are not specific places. They're not specific numbers. But saying the number is going to negative infinity means just it's getting bigger and bigger and bigger negative numbers. Negative 1 million, negative 2 million, negative 500 trillion. Probably bigger numbers than that because our national debt is more than that. Okay, so here's how I do the interval notation. I put the number on the left first, which in this case is negative infinity. I put a comma between them, and I put the end of the interval, the number on the right. In other words, I leave out the whole number line. I just tell you where does the number line start and where does it end. It starts at negative infinity. It ends at 5. Now, what you also have are going to be enclosure symbols. Sometimes you're going to have enclosures that are just regular parentheses. Sometimes you're going to have enclosures that are brackets. And sometimes you can have a parentheses on one end and a bracket on the other end. So how does this work? First of all, wherever you have the infinity sign, whether it's positive or negative, that always goes with a parentheses. Where you have a regular number, you will sometimes have a parentheses and sometimes you'll have a bracket. And it will depend on whether that number is filled in or not. A filled in number goes with a bracket. An open number goes with a parentheses. So this interval notation is giving me the same answer as this. X less than or equal to 5 is the same as the number line where the number, you have a closed circle at 5 and an arrow going to the left, or the interval, which is going from negative infinity to 5. Let me do another example. Suppose I gave you X is greater than negative 3. And we wanted to do this in interval notation. I always like to put it in on the number line first. So the way X greater than negative 3 looks is I go to the negative 3, which is on the left side of the 0. Since it says X is greater than negative 3, that's just an open circle, not a filled in circle. And this looks an arrowhead pointing to the right, so we draw in. X greater than negative 3 means any number that's bigger than negative 3. And of course, it includes all the positive numbers because any positive number is greater than negative 3. That's how this looks in as an inequality, and here's what it looks like on the number line. How does it look in interval notation? Well, remember, we always start on the left as our first number, even if it's an infinity, and the right is the ending number. In this case, the number that's all the way to the left is -3. The number that's all the way to the right, well, it's going on and on and on, so it's positive infinity. So again, you're going to always have two numbers. Sometimes one of those numbers is an infinity sign, but it's considered a number. You put the number on the left side, the number on the right side. Now we put in our enclosure symbols, our parentheses. At the infinity, as I said before, just like at negative infinity, at positive infinity, that's always a parentheses. In this case, at the -3, it's also a parentheses because it's an open circle. An open circle means the x is not included. That's what the parentheses means. So here's what this would look like in interval notation. Okay, I'm going to stop right here. This is where we're going to continue on Tuesday. Our next class is on Tuesday. I think what's the date of that? Is that August 31st? Today is the 26th, that was the 24th. Yeah, it's the 31st is our next class. The only homework that you have to do now is to make sure you know how to get onto your Blackboard account. Sign up if you haven't for Delta Math. Again, you're going to see on your Blackboard account, there's this sheet that you can print out that I'm going to be continuing to use in class. So if you print it out, you'll have some of the problems that we do in class. And again, I don't think, well, maybe I will assign some problems just in regular equations on Delta Math. But first, make sure that you've signed up for Delta Math. If you have any questions about anything, just email me. Just email me. Does anybody have any questions before I end class?